Quadratic equations are trinomials in the general form ax squared plus bx plus c. When we're asked to solve them for x values, we can do it a couple of different ways. The most convenient way, in my opinion, is simple factoring, but some people aren't very confident or well practiced in that method, and in other cases it's quite difficult to evenly factor out quadratic equations. So let's look at a method called completing the square today. And here we have a quadratic equation where a is equal to 1, and we could factor this quite easily. You can see that something times something equals 5, and that something plus the other something equals 6. So 5 times 1 equals 5, and 5 plus 1 equals 6. This would be easy to factor through the standard technique, but it's not a perfect square, and so let's take a look at how to complete the square in order to make it simple to factor out. Okay, and so let's take this term and put it on the other side by subtracting 5. We're going to get x squared plus 6x equals negative 5. And now we're going to find the last term in order to make the left side a complete square. Remember, whatever we do to the left side, we have to do to the right side. So in order to do that, a simplified method is to take this b term, 6, and we're going to add as the third term that b divided by 2 squared. So it's 6 over 2 squared, or 9. And that's equal to negative 5. And we're going to have to again add 9 over on this side. All right? And so what we have here is, let's call this 9. X squared plus 6x plus 9. This is easily factored into a perfect square, x plus 3 squared, and then that's equal to negative 5 plus 9, or 4. Right? And so what we can do here is take the square root of both sides, and in order to do that and get a decent and easy answer, we've got x to the n equals k in each case. If k is greater than 0, then x is equal to plus or minus the nth root, or we'll just say, in this case, call this n2, the square root of k, plus or minus the square root of k. If k is equal to 0, then x is equal to 0. And if k is less than 0, then we have no real roots. We see in this case k is greater than 0, so then x is equal to, this whole term over here is x, by the way, so x plus 3 is equal to plus or minus the square root of 4, which is 2. And so what we'll have to do then is take our numbers, constants, put them on one side. So then x is equal to negative 2 minus 3, and also x is equal to 2 minus 3. Negative 2 minus 3 is equal to negative 5, and 2 minus 3 is equal to negative 1. And if we wanted to check that, just to make sure, we can take those two numbers, plug them into the original equation. Negative 5 squared is 25, plus 6 times negative 5. So 25 minus 30 plus 5, 25 minus 30 plus 5 is in fact equal to 0. And then negative 1 squared plus 6 times negative 1. So we got negative 1 squared is 1. 1 minus 6 plus 5 again is equal to 0, so our answers are correct there. That's where a is equal to 1. Let's take a look at a case where a is not equal to 1. So we have their a term here. Again, a quadratic equation is a trinomial in the standard form ax squared plus bx plus c. In this case, c would be negative 2. Okay. And so in order to take care of that a term, we want to divide this whole thing by 2. We want a to be 1. That's the easiest way to factor anything. So you've got x squared plus 3 halves, or 1.5x, minus 1 is equal to 0. Again, not a perfect square, so let's take this term, put it over on the other side, then we'll complete the squares. So we get x squared plus 3 halves x, and let's add that last term there. So we want to take half of 3 halves and then square it. Half of 3 halves is 3/4, and we're going to add to that 3/4 squared, or 9/16. And over on the other side, we've moved the 1s. We have 1, and we're going to have to add again to that 9/16. And so when we factor it out, we've got x plus 3/4 quantity squared. And remember, this term here, when we have a perfect square, is just half of this middle term. 1 plus 9/16 is 16/16 plus 9/16, or 25/16. So it's looking pretty simple here. We have k is greater than 1. Therefore, we can take a square root of both sides. We get x plus 3/4 is equal to plus or minus the square root of 25 over 16. And so the square root of 25 over 16 is 5 over 4, just the square root of 25 over the square root of 4. And we will solve for x. Luckily, we have a common denominator, so it's pretty simple. 5 plus 3 over 4, or 8 over 4, which equals 2. And our second x value is negative 5/4. Oops, that was incorrect, sorry. I should have subtracted. I can do like this here, like that, and I'll get a negative. Sorry. So negative 5/4, change that to the positive. Negative 5/4 minus 3/4 is negative 8 divided by 4, which is negative 2. And here we have 5/4 minus 3/4, or 2/4, which is equal to 1/2. And again, we can check that if we like. You can always check. So 2 times x squared, 2 times 1/4 is 1/2, plus 3 times 1/2 plus 3 halves, minus 2 is equal to 0. Good. And second value, negative 2 times negative 2 squared is 4, times 2 is 8. 8 plus negative 2 times 3, so plus a minus 6, minus 2 is equal to 0, and so that checks out as well. Let's take a look at another example. In this case, we have an irrational solution. Maybe we don't know that yet, but we're going to find out in just a moment. Right? And so we can see this is obviously not a perfect square. Let's take that term, move it over to the other side. We'll find the third term. We have x squared minus 3x plus 3 halves squared, which is 9/4. Oops, my plus. And then we've got 6 on the other side, and we're going to add to that 9/4. Right? So our perfect square is x minus 3 halves quantity squared, and that's equal to 6 plus 9/4, or 6 times 4 is 24, plus 9 is 33 over 4. We have k greater than 0, so we can take a square root of both sides. We get x minus 3 halves is equal to plus or minus the square root of 33 over 4, and we see that we can take a square root of 4 quite easily, but not 33. And so what we're going to say here is this is plus or minus root 33 divided by 2. And so we're going to add to that 3 halves. So x is equal to, and this will be our final answer. We have a common denominator, so we'll just put that 3 out in front. 3 plus or minus the square root of 33 over 2. We can't simplify this any further. There aren't any perfect squares inside of 33. There are no factors other than 3 and 11, neither of which can be, we can take a square root and come up with an integer solution. So that is our final answer right there. We could check it. It'll come out just fine. Okay, and here we have an equation containing a radical, and this doesn't even really look like a quadratic equation at first, but let's work with it a little bit. Let's get rid of this square root sign. And so we can get rid of the square root sign much in the same way as if we have a squared over here. We take a square root and we'll end up with a square root on that side, and it looks like we should just square both these sides. So we've got x plus 3 squared, and then that's going to be equal to all of this squared is just take away that square root sign, 153 minus x. And now we will do our FOIL method and come up with x squared plus 6x plus 9 is equal to 153 minus x. Let's take all of this and join our like terms on the other side. We'll get x squared plus 7x minus 144. 144 is a perfect square of 12, but we don't have a perfect square trinomial here, so let's take this, put it back over onto the other side if we want to complete the square, or maybe a little bit easier way to do it this time is simple factoring. If we can think of the factors of 144, so we've got 72 and 2, we can't do anything that comes up with a sum of 7 there. So we're going to have 1 plus, 1 minus, 72 and 2, the difference is too great. 10 times 16 is 160, and so 9 times 16 is 144. They have a difference of 7, so it looks like that's probably our solution set there. How about minus 9 and x plus 16? So if we wanted to FOIL, we get x squared plus 16x minus 9x plus 16 minus 9 is 7x, and then we have minus 144. And so we'll take x minus 9 is equal to 0, and x plus 16 is equal to 0, and that gives us x equals 9 and negative 16. All right, we can in fact complete the square as well, although it's a little bit messier. Let's complete the square up here. And so we've got x squared plus 7x plus 1/2 of 7 squared, so that's plus 49 over 4, and that's equal to 144 plus 49 fourths. Right, so here we have a perfect square, x squared plus 7 halves x, or sorry, plus 7 halves, quantity squared, is equal to 144 times 4 is 576, so we've got 576 plus 49 over 4. Take a square root of that, and I should get rid of that, sorry. So we've got x plus 7 halves. X plus 7 halves is equal to the square root of 625 is the sum here. Square root of 625, you should know that one is 25. So we got plus or minus 25 over 2. Alright, so x is equal to 25 minus 7 over 2, and x is also equal to negative 25 minus 7 over 2. 25 minus 7 is 18, over 2 is 9, and negative 25 minus 7 is negative 32, over 2 is negative 16. So it's a little bit messier, but you can come to the same answer either way. Look at our last example. Here we've got an equation containing a rational expression. Remember, rational expressions are ratios of polynomials. An integer can be a polynomial, or it's a monomial, excuse me. We could phrase it we could say that it's ax squared plus bx plus c, but a and b are both 0. So here we have rational expressions. Let's first find our least common denominator. Well, least common denominator is going to be x times x minus 2 times 8. And so we'll multiply our first term 1 by the other two denominators, x minus 2 and 8. We'll add to that 3 times the other two denominators, which is x and 8. And then we're going to subtract 5 over to the other side. We get 5 times the other two denominators, which is x and x minus 2. And all of this is over x times x minus 2 times 8, and that's equal to 0. So we're going to multiply both sides. 0 times anything is equal to 0, so that denominator just disappears. That's convenient. Now let's expand and combine like terms. So we've got 1 times 8 times x minus 2 times 8 is 16, plus 3 times 8 times x is 24x, and then minus 5x times x is minus 5x squared, and minus 5 times x times minus 2 is negative 10x. All right, let's combine our like terms. Oh, excuse me. Negative 5 times negative 2 is 2. This is then equal to 0. So let's combine our like terms. We'll put our x squared term in front, negative 5x squared. 8 and 24 is 32, and 10 is 42. Minus 16, that last one stays the same. And we have equal to 0. Let's multiply by negative 1 in order to get our a term positive. 5x squared plus, minus 42x plus 16 equals 0. And again, this is one of those cases where it's maybe inconvenient to complete the square, but we'll do that second. So we've got 5x and x. We've got a positive here and a negative here, so we know we have minus and minus. This all equals 0. 5x times what plus 5 times what plus 1 times what is equal to, that middle term there is 42. Alright, so how about 8 and 2? 5 times 8 is 40. Yep. 1 times 2, so 42. 5 times 8 and 1 times 2, the sum is 42. 8 and 2 multiplied by one another is 16. So you've got 5x minus 2 equals 0, or 5x equals negative 2. So x equals negative 2, positive. X equals 2/5, and x minus 8 equals 0, or x equals 8. So in my opinion, that's the easier way to do it, but let's complete the square since that's what we're doing today. So we've got 5x squared. Let's start with this equation here. 5x squared minus 42x plus 16. Well, we had an example earlier where we had to take the first term, take that a, and get it down to 1. So here we have a non-zero or non-1 a. Let's divide the whole thing by 5, and we get x squared minus 42 over 5x plus 16 over 5 equals 0, and this is not pretty, obviously, but let's, for sake of consistency, just complete the square. We're going to have x squared minus 42 over 5x. Find the third term. It's half of 42 over 5, which is half of 42 over 5 squared is 42 over 10, and so 42 over 10 squared is 1,764 over 100, not pretty, and that's equal to negative 16/5 plus 1764 over 100. So we have a perfect square, although it's definitely not the perfect equation to work with. 42 over 10 is half of 42 over 5. Square that, and now let's find our common denominator, which is going to be 100. So 5 times 20 is 100. 16 times 20 is 320. And so we've got 1764 minus 320, or 1444 over 100. 1444 conveniently is a perfect square, and so k is greater than 0. We'll take the square root of both sides. We get x minus 42 over 10 is equal to 38 over 10. Square root of 1444 conveniently is 38. Square root of 100 is 10. We have common denominators, which is convenient again. Sorry, plus minus. So x is equal to negative 38 plus 42 over 10, which is equal to 80 over 10, or 8. That's our first answer. And x is also equal to positive 38. Oops, sorry. No, excuse me. Negative 38, excuse me, that's our second one. Use my eraser here. Okay. Negative 38 plus 42 is equal to 4. 4 over 10 is equal to 2/5. That's the same answer as that one. And finally, 38 plus 42, as we already saw, over 10 is equal to 80 over 10, or 8. And so you can come to the same answer a couple of different ways. We can also use the quadratic formula. That's the third way to find solutions for quadratic equations.